first one is the top to bottom approach. So here it means that your input, its database, it's all the information, let's say spare part, that is already available in your company. So what we will do is we will screen all these existing database to be able to say, okay, this part makes sense for additive manufacturing, or this part doesn't make sense, and why. And the other approach, it's the bottom-up approach. So here it's what we call use case screening. It can be an operator in a production site. His tooling is broken. He needs a replacement as soon as possible. So he is able, through a form, to fill the form and also put that as a request for digitalization and 3D printing. What we, or let's say the market show, it's between 5 and 10% of parts are ready for AM when we look at inventories. Now I'd like to deep dive on how we work from part inventories or database. And this is, believe me, not magical at all. When we work with our customer, this is the first step, and a very, very important step, is to understand first what is the business goal of the industrial company. Why they want to digitalize their inventory. Is it to focus on lead time? Is it to focus on new project? Is it to focus on cost saving? Is it to focus on the parts that are critical? So some of them are different focus, different goals. Some of them have only one unique goal. So once we have defined this business goal, it's all about finding the data in the existing database. So which data I need to then analyze the part, and where is this data located? And in big companies, it can be an ERP like SAP, it can be an PLM system, it can be an in-house system, so it can be in very various systems. So it's all about knowing which information you need to do the identification, knowing where is the information, and be able to configure it to then do the data acquisition. And the data acquisition, it means that you import automatically and you massively all the database that you already have. And then we do that to go to this step, which is the part assessment. So which part can I digitalize and can I 3D print? So here you see an example of a dashboard of one of the parts that was automatically imported, and you see 3 main columns. So on the left side, you have the general information of the part. What is the status of the part? Is this part approved? Is it registered? Why? Who is the main responsible of the part, and so on. In the middle, you see some technical and economical information. And on the right side, which is the most interesting here, it's the reporting. So for each part, we will give a score between 0 and 100% based on technical information and economical data. So behind the back, you have algorithms that are working to be able to assess if the part is interesting for additive manufacturing. So closer you are from 100%, more the part makes sense for additive manufacturing. And then we also, for each part, assess if it makes sense for one specific technologies in additive manufacturing. So you see on the bottom right, the DMLS, SLS, FDM, and we also do the AM price estimation. So all of that, at the end, it's to really build the business case. So know if the part is printable, highly printable, not printable, and know if it's a good business case. If you will save money, save time, if you 3D print the part. Now, just to illustrate a bit the part identification and the part assessment, I'd like to give the example of one of our customers, SNCF. SNCF, it's the French railway company, and we work together on mainly reducing the cost of spare parts. One of the main challenges, and I was mentioning before, the big step of the data preparation, it's all about poor technical information, messy ERP data, lack of AM knowledge. But we were able to build a digital platform of 30,000 spare parts and assess this part. And what we found is what you see on the right, 10.3% of this part are AM relevant. We also see, like analyzing the lead time, that the average lead time it's 2.5 months when we expect 10 business days in additive manufacturing. And we also saw a lot of savings that we are not able to display here. So now let's come back to the graphic. So you have identified between 5 and 10% of interesting part or AM relevant part. And now you want to go to the next step, which is you want to build the AM ready of digital inventory, you want to build an AM ready digital catalog or inventory of qualified parts. So it means that the 5 or 10% of parts you identify doesn't mean that these parts are printed and are printable. So there are like some steps in the process, like qualification step. You can also need to do some quality check. So all the steps to, at the end, say, okay, this part is printable, and I will store all the information. And this is what we are seeing at the beginning with the definition of digital warehouse. And so in this AM ready digital inventory, you will store the qualified AM part. And you could, for example, store the 3D file. You can store all the information regarding the process, the material, the technology, the production requirement. You can also mention who are your qualified print service bureau to print the part. Here, this interface is very different from one customer to another. It also depends a lot on the security. So which data you want to display here. But all the meaning of this interface is to have a catalog, AM qualified part where you can order from. And this should be like structured, secure, and of course traceable. So now that you have your AM ready digital inventory, the next step will be to order from this inventory. And here, or you order a part and you have your internal 3D printing capacities. So you will print the part in-house, or you will have to ask external suppliers to print the part. This is what you see on the right. And so when you will ask to print the part, you'll basically send all the digital information to the production site. And of course, here you have a lot of questions about the intellectual property on the part. So which data can I send and which data I can't share with my manufacturer. And so here we see more and more companies that are really focusing on to securize the workflow between a part is ordered and a part is printed. And for example, in France, we have a company called Vistory, which that use blockchain to focus on the security of the workflow, and to avoid that a part or a 3D file is modified just before the production. And then, of course, you distribute and you send the part to your end user. To finish, I just would like to go to this data, which is this slide. It's come from 3Omine. So the main, let's say, output of the digital warehouse, it's like data is in the middle of all the digital warehouse, and data can be provided when you identify the business case, when you do the part identification, when you create your AM ready digital inventories, when you will order a part and manage your suppliers, when you will produce the part internally or externally, and so on. So really the digital warehouse, like the base, the core of the digital warehouse, it's all about data. And at 3Omine, we have solutions to really be able to help our customer to do through all these steps and build this digital platform to store parts. So that's all for me. So if you are ready to move from physical to digital, feel free to talk, I give my email address here, and I will probably be in the 3Remind booth a bit later. And if you have any questions, so I cannot see the question right now, so I will stop presenting.
Thank you so much, Marie. Great presentation, a lot of great insight here for all our attendees, and to whomever will listen again to this presentation later. I would like to understand a little bit better what 3Remind does, and like who are your customers, who is using right now the digital inventory?
Yes, a good question. So today our customer, so let's say that today we have three main focus of customer. The one is the defense industry, the other one is the railway industry, and the last one is the oil and gas. And our customer can be an end user. I mentioned SNCF, can also be an OEM, but both wants to digitalize, and both wants to reduce their costs and have parts delivered as soon as possible. So this is the first goal. And they go to 3D printing because it can offer the possibility to print on demand, to reduce the storage of parts, and so on. So our customer, yes, are like industrial customer mainly, that are under a lot of database, and that will need to digitalize and find a cost reduction or lead time reduction.
Awesome. And I see we have a question from Carol. How to handle parts that are generative?
So maybe I'll give to answer and let me know if it's clear, but I will give so today I really focus on spare parts to talk about digital warehouse, because this is, let's say, the use case that we experience the most. So when we talk about spare parts, sometimes you don't have 3D file. So it's all about, okay, I identify a good business case with this part, and now I have to create the 3D file, and sometimes I have to optimize the design. So this is a part of the process, but first you need to see if it has a business case. So if it's not economically interesting, you won't move forward. But if it is, sometimes if you don't have a 3D file and you are able to modify the design, you can do it. Sometimes you are not able to modify the design, so you have to print as it is, and so on. We also have customers that use the digital warehouse to put new parts and completely and do reverse engineering and so on. So this is different strategy that we see at our customer.
And I see in the chat that Devin mentioned digital twin, and this is a buzzword in the industry. Are you is your software apparently also helping creating this digital twin?
So yeah, it's a buzzword as 3D printing, to be honest. When we talk about digital warehouse, we talk about IoT, digital twin, 3D printing. So it's what we see is like the companies that are moving to 3D printing. So they have 3D printing project, and in parallel they have digital warehouse. It's digital twin, 3D printing, and other technology. So it will go together. But today, let's say that at least 3Remind, we are more focused on digital and 3D printing. You have like a company only focusing on digital twin. But of course, at some point, it has to work together. So you want one digital warehouse that can handle everything.
Indeed. And I see more questions coming in. For your customer segments and for polymer parts, which additive technology do you see as most usable? Which is most promising today for the future?
Good question.
That's a good question.
Yeah, very good question, Daniel. To be honest, it depends on the. So I don't have the answer, but what we can see, it depends on the sector. For example, in railway company and oil and gas, we see one very interesting, because usually the spare parts are very big. It makes sense, and sometimes it's about repairability. So one is very interesting. Now we are focusing a lot on additive technology. For example, for a railway, we know that rapid casting, so build the mold in 3D printing, it's super interesting as well. So the digital warehouse should take into account direct 3D printing technology as well as, let's say, indirect additive technology. But to answer Danielle, I'd like to say it depends really on the application, the use case of the customer. For some of them, some of our customers, they are interested on just one technology. It can be MGF, for example. It really depends on the use case and the business goal.
Indeed. I will go to the next question from Gregor. Can all aspects of business case be analyzed by software?
Yeah, good question also. The main limiting factor, it's the input data. So if the customer is not able to give us the minimum order quantity, the number of parts in stock, and all the supply chain, the economical data, we will not able to analyze and to do the analysis. So when we study the business case, I talk about spare part, but we always start with the existing data, existing economical data. And usually, of course, it's the part price, it's the minimum order quantity, it's the lead time, how many parts are in stock, what is the demand, the expected demand. And for some customer, we can even go much further. So who is the manufacturing, what is the ordering plan, and so on. So it really depends on the information that we are able to catch at the beginning to do a very, very detailed business case.
And I see Daniel asking, I see the liquid processes such as carbon or figure 4, I think, well, I don't know if it's referring to your presentation, showing much promise for my type of parts, so quite small ones and medium-sized quantities. What experience do you have with this kind of processes? So liquid processes, so SLA, I guess, technology.
So we have demand on that. So in the software, 3Omine, it's a digital platform, and we work with experts from the manufacturing technology, the manufacturers, to be able to really add the technology checks that you saw in the software. So for each part, we are able to say if it's good for DMLS, for SLA, for SLS, and so on. And we work with for example, with Carbon to do that. And Carbon is a partner of 3Omine. So we work with them directly to put all the knowledge in the software to be able to assess a part. But to answer, yes, we have experience because we have customers that are interested by this technology.
Awesome. So figure 4, Daniel clarified, was referring to 3D systems technology. So I think if that's all on our side, the questions. I see here a clarification from Carol on Agile PLM. Do you understand the question, Marie?
Agile PLM, that is not Oracle. No. Agile PLM, it's the own module of 3Omine. So at 3Omine, we basically have 3 modules: Agile PLM, Agile ERP, Agile MES. Agile PLM, it's more on part identification. Agile ERP, it's more on order management. And Agile MES on production management. So to build a digital warehouse, we used to have these 3 modules, but it's not Oracle.